Okay, 9b. 9b is a very hard one. Let's see 9b. So first of all, gotta understand the question also. So we gotta understand one. So he say this build this function fn, right? What does fn mean? Is the number, the positive integer that have n digit, whose digit sum is 5. This way 5. So this is the function, right? So then we prove how many this have this unit digit is 1. So that was tough. So first of all, we have no idea what's going here, right? We're gonna try first. Try first. What does that mean? So let's say f1. What does f1 mean, right? f1 is a mean. He say like one digit. f1 mean one digit. Digits be 5. f1 just be 1. So only 5 would be there, right? That's f2. f2 this time we allow 2 digit, right? Is it allow 2 digit? We have exactly 2 digit. Sum equal to 5 would be what? 1 4 4 1 2 3 3 2 and 2 digit 0 5 cannot count. So this is the first. This one cannot. 5 0 is okay, right? Okay, good. Then we say f3. f3 is what? Whoa, f3 this time will allow 3 digit number. So we have what? We have this one still count. This one we add a 0. Same thing with this one. Add a 0 will be okay. 5 0. So first 5 0 0 1 and 1 for this. Both one we put a 0 0 in. We have 4 already. Now 4, right? So 0 can put a here. No, cannot put the first one. So 0 can put 1 0 4 1 4 0. So this is 5 times 2. This is 8. Now we have another one is called what? 3 digit. We have like 3 digit. We have 2 2 1 also exists, right? 2 to 1 is okay. 3 1 1 also okay. Right? 3 1 1. This one also okay, right? So this is how many times, right? This is gotta be 3. This one's 3 because this is a combined would be 3. This one would be 3. So add up like 15. Okay, so basically f1 this is 5, right? f3 be 15. f4 keep going like this. So he finally he want to ask this all this number have digit. How many digit have 1? How many last digit unit digit is 1? Is that a unit digit call? Yeah, unit digit. So it's 1. So first is 1. This one definitely okay, right? This one is good. And the rest, this one no. For the 4, we don't know what number here, right? So here. But we gotta figure out how we can get this one, right? So luckily this is a 5, so we can kind of can brute force that. Can brute force. So if we no idea what's gotta do, so we can brute force. So basically, how can you make 5? So 5 is here. 5 you can make 5. Right? What kind of digit? 4 1. You can make 5. 3 2. You can make 5. Right? It's kind of order, right? Order, sort order. This is kind of sort order, right? 4 1. Now it's 3 2. You cannot try anymore. So you gotta try 3 1 1. Right? 3 1 1. 3 1 1 1 already go to the end though. So you gotta decrease this one. You can say 2 2. You gotta try 2 first, right? You cannot bigger this one. So basically try is always from 5 and try, okay? 5, 4, keep trying, and the next digit cannot bigger than this one. We're sorting order, all right, sorting. So this 3, and next one should be 2, 2, 1, right? And 2, this one cannot, this one cannot increase anymore, so gotta be 2, 1, 1, 1. The last one, no more. It cannot increase anymore, so it gotta be 1, 1, 1, 1, 1. Totally it should be this 7 case, right? Gotta be this 7 case. Then what happened is we can put a 0 in between. So 0, add a 0 in, right? So now we're gonna think about it, okay? Think about it, this n digit. So basically we have n position here, n position here, n position here. Wow, this n position here, right? It's n position. So we want to put this our number in some position here, right? Maybe here or maybe somewhere else. Like we put this position here, then we fill a bunch of 0 there, right? So basically the rest should be 0, right? The rest should be 0. And let's say we fill, so we'll realize for n position here, the first one must fill. Must fill. If don't fill, this one be 0. Doesn't mean it's here. 0, 5 doesn't count, right? 0, 5 doesn't count here. 0, 5 doesn't count. Crossed. Okay? 0, 5 cannot. So we must put it here. The rest, we can put any number here. Once we, let's say for example, 4, 1, right? Let's say we put a 4 here. And 1 can put anywhere here, right? 1 can put anywhere here. Then the rest just feels 0. So we got out of possibility. So this is kind of like the idea how we do that, right? Let's try 5. So 4, 1, right? 4, 1 and 1, 4 also count. So combination. So we pick up the position, but combination we gotta come back. So we have first we need a combination. So we build a table here. We say combination. What kind of combination here? What's combination here, right? Combination, combo here. So 5 is only one combo, right? This is 2. This is 2. This is what combo, right? If the both is same, if the two numbers is same, we just pick one. 3, 3, 3. This one 3 number is 4. And what about this combo? No combo. 1. Okay. So what combination we have, right? Now we need to figure out the position. We need the position. What position you have, right? For the 5, there's no position. Just 5. You gotta fill the first one. So got only one position. No way, right? For this one is like you gotta pick this, and the rest is this one. We gotta pick a position here, right? This position. Now we talk about position, right? We're not the number. We got a position here. We gotta pick 2 number position. The first one gotta pick. The rest one, pick 1. So it's n minus 1, pick 1. Right? This n minus 1, pick 1. For the 3 number, the first number gotta always pick. Then the rest one pick 2. So this is simple. n minus 1, pick 2. Right? The same. This n minus 1, pick 4. And I'll pick 4. Pick 3. Remember, first one must pick. After first one picked, only left the spots as n minus 1. So this is n minus 1, pick 4. Okay, now we just, this is all the possibility, right? Now we just do the math. Now we do our own math, right? Do the math. Should we do that math? Holy man. Kind of hard, huh? Okay. Let's do that one, okay? Let's do the math. This is a basic one. Okay, here, this is 1. Okay, then what is this one? This is 2 times n1. This one's same, right? Let's go 4 times n1, right? So we get 4 times n1. What about this? This is n minus 1. Pick 2, right? N minus 1 pick 2 is what? What is n minus 1? It'd be n minus 2, right? It will pick 2 here, times 3. Consider the next one same, we got 2, get rid of 2 here. So this is this answer, right? That one is special, this is holy. Pick up 3, so 4 times 6 n minus 1 n minus 2. Oh man, this mouse. N minus 3. Yeah, let's try to change this. N minus 3, then what? Right? This is only 1, right? The last one is holy, it's 24. Bunch of them, right? Then you need to add it up, right? When you add up, this n minus 1. So it just holy. What do we gotta do? We gotta put everything 24, merge them together, and we got one answer. Anyway, here is how to write, but anyway, just do the exercise. So expand this one, put this one, and at the end is kind of like you got a 24. At the end, you sum this up. At the end, you got a 24 and 4. Yeah, episode 4 come from this last one, and plus 6 and triple plus 11 and 2 and 6n. Yeah, here, see? Yeah. And this one you gotta realize. Also this one you gotta realize. That was tricky. And this one you gotta realize is look like n plus 1, n plus 2, n plus 3. Okay? So the final answer Fn supposed to be n plus 1, n plus 2, n plus 3 divided by 24. Okay, this is brute force hard, right? So spend a lot of time to figure out this one. Actually, how we can figure out this formula? This formula is standard. You keep analyze and you do the brute force. Is like keep saying like this one, right? You got an idea. But actually, this is that look like a star in a bar? Hey, what is star in a bar, right? So we gotta come back looking what is star in a bar. Star in a bar is bunch of 1 here, you have bunch of things here, right? So you gotta separate this one. If you separate to 1 group, to let's say separate to 2 group, 3 group. If you set the 3 group, what do you gotta do? You gotta put 2 bars somewhere, right? Put bar here. If you put a 2 bar here, what do you got? You got a 2, 2, 1, right? 2, 2, 1. Is that what's looking for? 2, 2, 1, something like that, right? Okay, star and bar. But star and bar have like a logic here. Why this star and bar formula is what, right? Formula is like this is how many you already have, right? 5 you already have, right? How many bar you put in, right? How many bar put in plus bar, let's say n plus 1. Then we choose bar. Hey, sorry, this one should be like this. This is the formula we got. But going this time, before we don't remember the behind what that means. So right now we gotta fully understand behind. We're gonna modify that because this one have a construction, right? So what do we do here? We can do the for the 2. We can do 2 tests, right? So here 0, 0, 0, 0, 0, right? So remember here we already got the answer. So first 2 is 5. So we can do the star in the bar. We can see what is 5 here, right? So what the bar we should put, right? So bar put it here, we got a 0 and 5. You cannot. Then put it here, we got 1, 4. Put it here, we got 2, 3, right? Put it here, we got 3 and 2. Put it 4, 1 and a 5, 0, right? 5, 0 is put bars here, right? Okay, so the position for the bar only have this, so the key is this one cannot, right? So we'll start in a bar. Let's start by the formula. How you can get the formula? The formula is bar is always there. So if you cut to, let's say, 3 group, if you need to cut to 3 group, you always need a 2 bar, right? Always need a 2 bar, okay? And the number it can be anywhere, right? So this number can be anywhere. So this 5 supposed to be either here, 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 everywhere. So that's why you build a position. This after this 5 fill in, you got each position. You have like let's say 7 position, right? 7 position. This is 7. You have 7 position, right? You have 2 bar when you try to pick, right? Because 2 bar here and you other number here. That's why you have 7 position. Then you pick up this one if you 2 bar. If you put 2 bar here, 1 bar here, right? Because first one count is 0 and this is 0, 5, 0. This is 0, 5, 0, right? If I draw this one 0, 5, 0, okay. So that's why how the bar working. So this starting about special things. You don't want to have 0 here, right? If you don't want to have here, bar still there, right? So bar still there. So if you have 2 bars still here, but this position you gotta put a 1 here, right? This one is free. You gotta put a 1 here. Then the 4 number. This 4, this 1 gotta put a first one, and the rest, that is the remaining you have. So this is only 4 you have, right? So you gotta understand this one. So we only have 4 number there. Then you can do your back to your funny thing, because 1 is always added. Imagine 1 is always adding back, right? So the first one always, the first digit always cutting 1. This one can be here. For example, you have 4 to do the. Actually, it's 4 to the star in the bar, right? It's 4 number to the star in the bar. If you don't go through the picture, you can do original ones. 4. 4, what do you have? 4, you have 0, 4, 1, 1, 3, and 2, 2, 3, 1, and right? 4, 4, 0, 4, 0, 4, 0, right? You have this. If you do 4, you have this 5 option. But 1 is always adding back. 1 is always adding back here. Let's say 1 is here, 2 is here, 3 is here, 4 is here, 5 is here, right? That one back to our, this one back to our original, this, right? So what we can imagine is the first one always put a 1 bar there. The rest one we do the star in the bar and put 1 back. So it exactly got this position. Also, if you're familiar with the star and the bar logic, you say like first one already take, then you have the rest one, right? So the formula actually suddenly becoming very simple. It's 4 number, only have 4 number because first number 2. So the combination will be 4, and you will choose 4, which how many bar we should have? N, right? For n, if you want to cutting for the n digit, you want n minus 1 bar there, right? Then you pick n minus 1. So this is the formula, right? So this is n plus 3 and n minus 1, and this one is same as n minus 3. Pick 4, right? N minus 3, pick 4. This one, if we know the star in the bar, we just don't need this long calculation and then combine together. Also, you need a factorization. If you don't know how to factorization, you still cannot analyze this one, right? So you can one time, just like 1 second, can 1 second go to this one. This actually is n plus 3, choose 4. N choose 3, 4, so 3, 2, 1, and choose 4. So, yeah. So that one, smart, not smart, is totally is different, right? So we spent a long time to do here. Actually, some guy just here, boom, just without analyze, he just one time. So jumping to here. So yeah, we spent like 20 minutes, go here, and he spent like 1 second go here. It's totally different, right? And you can verify this one. Yeah, you can verify this one because we have like we have 3 is 15, so you can easily put 3 is 15. Is it right or not right? 3 is 15. So 6 choose 4, and it's same as choose 6 choose 2, and 6 plus 5 choose 2, and it is 15. So basically you have this number. So this is correctly, okay? This is the first part. So we gotta understand all the formulas like this, right? Okay, now we go to, now we haven't done yet. Even we figure out the formula, we just gotta get the partially point, right? So right now let's write down again, n3 and n plus 2, n plus 1, n, right? This is our formula, star and a bar, okay? Star and a bar, so very important. Although star and a bar very simple, but sometimes it's very useful, star and a bar, right? Star and a bar, you can do your imagination, right? Star and bar is allow 0. Star and bar is allow 0, right? Allow 0. We usually do is every power have 1, 1, 1, 1. So you gotta get rid of, you minus all the 1 and convert by, let's say you have like 16. 16, you want a 16 one, you're gonna separate to 4 power, and every power at least 1. So what do you gotta do? You gotta say 16 minus 4 equal to 12. Then you go to 12, back to our 0 allow. This is special one. Today this question is special. Only first digit cannot be greater than 0. The rest digit it can be 0. So what do you gotta do? You only minus 1 is okay. Yeah, we gotta, this one gotta be important. Okay, very important. This is very important. So sometimes star and bar, how this working, gotta memorize. Looping, yeah, very important. Okay, now we analyze this one. So for this one, how many number we like last digit will be 1, right? So we wish we have computer to calculation F1 like looping this one, but he asks you to do manually analyze, right? So we passed here already, got the got some point, right? After what do we got here, right? Now we have like this one is another jumping point. You gotta understand. You see your previous test here, right? So you can test bunch of a little bit. So here you can test things here, right? You can say, okay, basically if you cannot get this one, don't be lazy. If you cannot guessing how you do that, don't be lazy. You're gonna try 1. Anyway, we won't try 1 to 2014, but we try 1, try 2 until we saw some pattern here, right? We saw some pattern here. 2 is what? Right? 2 is what is that? 2, 3, 2 is 2. Hey, wait, choose 2. No, sucks, man. This is not good. We just like when we try, we have like n plus 3, choose 4, right? So 5, choose 4, it will be 5, right? F3, we want to try 6, we'll choose 4, we have something, and something will be have 4, 15, right? 4, choose 4, right? 7, choose 4, what is what, right? 7, choose 4, 7, choose 3, so 7, 6, and 5, and 35, and F5 choose 3 will be something like, it keeps saying, keep going, right? We keep going. So basically, if we no idea, we gotta try. But we won't try all. Just try like until 10. If you still cannot see, then we just give up, right? So the A choose 4. A choose 4 is what? A765, and this is 4 3 2 1. So the 4 3 2. This one gone. This one 2. This kind of 70 like this. Yeah, I keep going here, right? Then we realize this kind of 5 6, right? Yeah, we can 5 6, right? 6 is what? 9. 9 choose 4. 9 choose 4 is 9 A 7 6. 4 3 2 1. This one here, and this is 2, right? This is how much? And 126, right? We're gonna keep try until so basically we can keep try until the looping part, right? Until the looping. So you will find something bad. Definitely can find some pattern, right? Keep try. Yes, keep try, and build a table. Keep try if you want to get this point. But also, if we quickly got this one, we say, oh wait, this is 5. Yeah, 5. Actually, you can keep try. Okay, keep try. I think keep try also doesn't. Yeah, maybe it cost some time. Yeah, I don't know. This one, all relate with 5. We suddenly realize this 5 impossible, right? So this is for 2, 3, 4, 5. This cannot because they have 5. Here, this one is 1 times 2 times 3 times 4. If inside got 5 here, it cannot be divided by. So this 5 will be always exist. If 5 always exists, then the number will be either to be 5 or either to be 0, right? You got no chance to be. So how come, right? So let's say 2. Why 2 is 5? 2 because add this one is 5. 3 add this one is 5. 4 add this one 5. 5 add himself is 5. So basically only 1 and 6 you won't have 5. So only 1 and 6 don't have 5. So basically we can get rid of all this one. So right, at least this one can get rid of. We can try it 1 and 6, right? Only 1 and 6 is working. Only the 1 and 6, 1, right? So we only like the 1. The 1 is not the 1. The 1 is mean like 10 n plus 1. N cannot. What's it k? 10k. Or 10k plus 6. Right? Only this one is okay, but they didn't get the answer, right? This is one get answer. This one didn't get answer. So with 10 plus 1, have this one 10 plus 6, have nowhere, right? So we will continue to doing. So what happened? So at least we get rid of this one. So not many, right? So we have 10k plus 1. The last digit is 1, last digit is 6. We realize this one is this one. Yeah, that one is already improved a lot, right? Okay, go next one. What do we gotta do? Now what are we gonna do, right? We're gonna still try it and testing, right? We're gonna try here. Let's say here, we're gonna try it. Don't forget, we keep trying, right? This is 11, 21, 31, and 41, right? And 51, we keep trying, right? What is 11? Say, let's see 11, what happened, right? 11, yeah, that's one equal to 330, right? Obviously F, right? We forgot to write F, okay? Just keep doing this one. And what about like 21, right? 21 choose 3. You have like calculator. Hey, is that allowed a calculator? I think you allowed, right? 21. 21 choose 4. 11 is 1001, right? 21 will be 21 will be what? How come? 21 will be 1. second. Yeah, 21 will be 10626. 31 will be what? We have calculator, right? We don't need to use that. 31 will be 6, 4, 6, 3, 7, 6. So 41 will be what? 41 will be, yeah, 41 will be 10127. 51 will be, no, 41 no. 41 is wrong. 41 is 44, choose 2. Should be, this should be normal. 42 should be 1, 3. So m plus 3, forgot. So we've got to build a table. Here we forgot to build a table. So like easily cannot get. So this bad habit. 3, 5. If we have, yeah, my pencil not good. Oh, 7. Yeah, here, 41 is 1 back, 1 and 41 back, so 11 is okay, and 51 is 54 here, so 54, yeah, this one working, this one also working, this one is 316 something, this one working, and you can try, right? So we can guess this is this one working, 316251. So working. So basically we can guessing because this guy asked like with proof, right? With proof, hold it. With proof. So we gotta prove this one we can guessing here. This guessing don't need to write on paper. And this one here, right? We can guessing like yeah, if we try like 61, blah blah something like you find a 61 not working, 71 not working, and 81 working, right? So yeah, since we already here, we already figured out this formula so difficult, so we'd rather get this answer, keep try, right? If we want to keep try here, so first we try here, we figure out, oh, it's 5 gone, and here we have to keep 10k, keep try here, oh, see 40, so 40 is kind of a loop, right? 40 is a loop, so kind of 40 is a loop, so this is a guessing, right? 40. Okay, now we try to say 40. So now we have guessing 40, right? So we can say 40k plus 1, right? 40k plus 1, okay? So basically we can prove, we gotta prove this one is working, right? So we based on 10k, right? So we have tried 10k plus 1. We know 10k plus 1 might working. This might be working, right? Right now we prove this one absolutely working. After we prove 11, 21, 31, right? If you back to the 41, we don't need it because it's back to here, right? If 41 is back to here, then we have 10k plus 6, right? Now we gotta try like 40, right? Now 40k plus 1 plus 6, 16, 26, 36. 46 don't need it. 46 we're back to here, right? Okay, right? We try 40. How do we do 40, right? M plus 3, right? Remember our formula is this formula, right? So m plus 3 is 40 is what? 40 will be equal to 40 plus 1 is 3 is 4, 40 plus 3, 40 plus 2, 40 will be plus 1, right? 1, yeah. So for here, right? So what about this one? This one is like you gotta divide by. The problem is divide by something. We gotta divide by something. Once you divide by finish, you will know the last digit. For the last digit operation, if we have 10, if we have this one, if we have 10K, like if we only do this operating, then we just we can get rid of all this above, all this one. Let's say we have 1, 7. So if we want a calculation last digit, this one should be all gone, right? We only take the last digit. For this formula, difficult part is it gotta be choose 4. Choose 4? Yeah, choose 4. So choose 4, it will divide by 24, right? So we don't need it. So but divide by 24. That's exactly give us the idea is divide by 24, right? So divide by 24 is like we have this one. So we need to divide by this one, right? So this have like 4 times 3 times 2 times 1, right? So 4 you can go 4 you can go here, 2 you can go here. What is 3 will go? 4 go here will be 10K plus 1, right? 4 go here. Okay, we got 10K plus 1. This one got to be 20K plus 1, right? And this 40K plus 1. Where's 3 go? Actually the 3 is that we can change the question. We can change the question. We don't need to looking for the last digit is 1. We can looking for last digit is 3, right? So if this one last digit is last digit must be as 3, right? This is another part. When you analyze this one, you gotta turn it around. Right here, we don't have 1. We don't have some divide by this one, right? If you turn to 30, if you turn to 30K, you can divide by 30, but 40 not divide by. So we divide by 40, divide by 4 is like you get rid of this 2, right? 40 design is very good here too, but it's 3 here. Since this one, the last digit, this last digit is 1, so if we times 3, our last digit gotta be 3, right? Must be 3, right? So we need to have 3 here, right? So definitely it could be 3 here, right? Yeah, reverse you also can say if something, if all the digit divided by 3, if the number divided by 3, if the number divided by 3 is all the digit add up will divide by 3. If we build this one, in 3, then because this one divided by 3, this one must divide by 3, right? If this one must divide by 3, this all gone already. This mod all disappear, only left this one, so we'll have like 3, right? So this one only left will be 3. So yeah, you do the like from this back forward, you also have 3, right? So basically, so we now changing the question. We changing the question. We say, okay, only build for 3. This is another turning point, right? Build for 3. When you build for 3 here, now we have this one working because this is 1, this is 1, this is 1 last digit. This one is 3. So this one 3 works. So that's why 40K absolutely works. Now we need to prove this one not working. Is it working or not? 11 is working or not working? 11, it works, right? So we gotta prove this one. This one works. This one not working, right? So this one. Here we also can prove like plus 6, not working, and working, right? Working and working. So for example, let's say any pick up anyone. This is the same thing. We do the same thing and the same thing, right? So let's say for this one, let's say for example 26 working, right? With random pick, so 26 working. 26 is 40 plus 26, right? And 40 plus not 26, sorry, 20. This plus 3, right? Plus F3. So suppose be 29, right? 29, 28, 27, and 26, right? So we would divide by this 4, 2, 1, right? This 39, right? yeah, so have here, what we gotta do here is this one is 10. If we divide by this one, will be okay. Let's put here. This one's don't moving. This one cannot divide by. It remains same. And this one will be 10 plus 7, right? And 27 stay there. And the 6 will be there too. 13, right? 13. So this above everything is so this one we done. We need a 3, right? We need 3. You see here is 9. The last digit will be 9. This one will be 7. This will be don't do anything because 3 we never saw. 2 we did here. 3 here, right? So 49 will be 9, right? This 2 will be 49. This 81 will be 1. 3 will be 3. Okay. Now we prove this one is 3 too. And now remember we change it to 3. Yeah, this is also working, right? So we do the exactly same thing. You do the same thing, then prove, okay? So what do? We prove, like, well, what do we prove? We prove 40. We prove this two working. Hey, look at changing the color. See, we prove this two is working, and this two. Wait. 26 and 36 working. Okay. Now we have looping, right? We have looping. We know what's going on here. So each 40 will be looping from 0. It's from 0, right? It's k from 0 because 1, 11, something. K from 0 to something, right? So we have this 2. Now we need to get an answer, okay? So we have 2, 0, 1, 4. So for this one, we have 50, right? 50. So 0k will be 0 to 50, right? If we do the 50, we have 2000, right? So 2000 is special case, right? So we gotta do the k to 49 first, right? K to 49, 0 to 49, k equal to 0 to 49. K 0 to 49 is not past 2000. 0 to 49, how many k have? We have 50k here, right? Every k we have how many answers? 1, 2, 3, 4. Have 4 answers. So have 4 answers here, right? So therefore is 2000, right? Okay, so 2000. But above when your k is 50, we have 2000. 2000, what number we have this one, right? 2000 we have like which one we good? 2000 we have this one is good. 2001, 2011 is good, and this 2026 and 36 is not good. So for the k is 50, we only have 2 is matter. So here the final answer will be 202. This is the final answer. Okay, that's conclusion. This is hard, right? This is very, very hard. So okay, so what do we gotta do here? The first one is like we spend a lot of time to guessing the formula, right? If we don't know what to do, so we can guessing, so we can brute force. For the 5, we say okay, 5, 4, 1 here. For every possibility, we try to keep build, right? So still in this question, still we gotta realize the first one cannot put 0. First one cannot put 0. It's put 0 cannot. This is special thing. Then you have all kinds of formula, right? Only less than n minus 1 position. So this one we add up. You got this answer, and you need a factorization. For this one, we spend a lot of time, 20 minutes on here. So this is you have a lot of time. Before you do very fast, right? Before you do very fast, you have enough time. You want to get this point, so we don't give up. So we have time. So use time to get this answer here, right? And you're gonna realize here. But after we introduce 1 second way is star and a bar. Star and a bar logic is what's going on here, right? So basically, star and a bar we introduce here, but every star, just remember, star and a bar is always 0, allow 0, right? For this kind of question, it's like usually what do we do here? Usually what do we do is star and a bar is yeah. This is what? Yeah. Usually what we do here is every power we allow one. So usually do that. So in this case, we gotta get rid of one. But for this one, is special case with the first one. So we just need only took one. Then we build answer, allow zero, and put one back. So it's exactly same as we have one, right? So for this question is like we have five one. So only have four one. But the first one already using. For 4-1, after 4-1, then we pick up, right? How many, so we can easily, we don't need to repeat that one. So this is the formula, very quick. This is 1 second, you got this one, and you verify. Bunch of you just verify by these things, right? The next one, since we got this one, I think if you got this one, then you have time to try, right? So we can try, if you, beginning we don't have idea, we have try 1 to 6. Once we try to 6, we realize 5 we can go, right? So we can quickly get rid of 5 because every 5 times everything either to 5 or either to 0. It cannot be 1, right? So this one, because this factorization is 1, 2, 3, 4. If above have 5, it cannot cancel. So it's always 5 exists. 5 exists, it will have this one. So we quickly, conclusion here is that this 2, only have this 2 is okay, right? Right now we brute force again, say like we try 1 already working, so we try 11, 21, 31, keep try. After try 1, we'll figure out, oh, look like 40 is a loop. Look like 40 is a loop. You can try a bunch of, but we can use a computer to try, right? So we can use calculator to try. So after you realize 40 is the loop, so we can get the 40 here, right? Just try the 40. 40 is the loop. Why 40 is the loop? So this guy asks you to with proof. So with proof, you gotta prove that why 40 is work. So with 40 and get this one, we divide by 4, right? Now after you for the last digit operation, we know that, right? This is a key. Last which operating is the key, right? Only calculation last digit. For this one, we can only divide by this one. Only the 3 cannot, right? Have 3 cannot, but we do the proof like 3. If we like if the last digit is 3, then we can get the 1. So this one we like prove, right? Okay, now we change it to last digit is now 1, last digit is 3. And for every one you can verify. This one definitely okay, this one definitely okay, this one cannot, keep reading. After you find out this 2 is working, this 2 is working, so you find out for each 40 cycle you will have the 4 answer, right? Now you can calculation for 0 to 49 and you have like 4 answer, right? And then last over 2000 you only have this 2 answer. This 2 cannot, this over the limit. Then you quickly go here. If you quickly get here, kind of like 20 minutes roughly. This question costs 20 minutes, maybe less, 15 minutes, 20 minutes, and it's good. It's worth it for like for 9B, this kind of hard question. It is good, yeah.